There we go. Okay. It is 11:30 and I think it's time that we get started. So hello everyone, I am Robert Wolf and I hope you are all having a wonderful day two at ARM DevSummit, this amazing virtual conference. Today, you will have joined the ecosystem networking talk about and I have my notes right here, make sure I pull those up, about cloud native development with Docker deployed on ARM. And this session is hosted by Marc Meunier, who I'll be passing the hosting duties over to shortly. Just to let you all know, this is a 45-minute ecosystem talk, so slightly longer than the 30-minute talks you might be used to if you've attended any of these other ones. We do have the opportunity to extend this up to a total of 1 hour with a hard stop at 1 hour. And if you do have to leave to another session at the 45-minute mark or even earlier, that's totally fine. Please feel free to head on over and do that. Now, for those of you who have questions, we do have 3 ways for you to submit questions. One is simply unmute your microphone, speak up. We love to have some conversation with you, so please feel free to speak up. Both of the speakers on the call have agreed to answer your questions if you'd like to do that way. You can also post your questions in the chat. There are a few of us who will be monitoring the chat for any of those questions, and then we will bring those questions to the speaker or topics of discussion. And the last one is you can directly message me. So if you want to go find Robert Wolf or Robert Arm, I think my handle is there, you can directly message me and I will bring those questions to the speaker anonymously. So perfect. Thank you very much. And I hope you enjoy the session. I'm going to pass things over to Marc. There you go, Marc.
All right. Thanks a lot, Robert.
Thank you.
This is interesting. We're seeing close to 40 people now joining in. This is good. A lot of people are still cycling through. So anyways, hi, everybody. I'm Marc. I'm part of the software ecosystem development team here at ARM. And what do I do every day is I bring projects together with multiple companies. So I work with the ecosystem. And we aim to solve issues or create new solutions together. Similar to what we're doing here today with Docker. So Docker is one of my key partners that I work with. So I'm excited to be here today with Justin Cormack, an ex-colleague of mine from Docker. Justin, do you want to say hello?
Hello, nice to see you. It's it's funny when it is an ecosystem. We end up all working with each other in the same place in different places, and so it's been working with you for a few years now.
Yeah, that's right. I think we were both together at TechCon last year, working for Docker and presenting the work that we did at Docker together and what the team developed for ARM. And I guess now what would be interesting is to talk about what's happened since TechCon. Maybe starting with what Docker's new vision is and what your plans are.
Yeah, so completely. Yeah, so just after TechCon, I guess it was, Docker was restructured a bit, and we now have a really straightforward, narrow focus really on building developer tooling, and that's really exciting because that's the bit of Docker that really was where Docker started and where its success was built from. And so we kind of got out of the business of running production runtimes, and we're now really interested in working with developers wherever they want to actually put things into production. So we're there to help them. So we're partnering with Amazon and Microsoft and people like that, but also lots of people are putting things in production on the edge, and there's way more diversity in production now. And as we're not a vendor sort of pushing solutions, we're in the business of helping developers put things to production wherever they come from.
Thanks, Justin. So a focus on the developers exclusively, and the rest of the business moved on. That's quite interesting, and it really does give you a chance to focus on a segment that needs these tools, needs the help. Before we dive into some of the advancements and pieces that have been brought together lately, Do you mind going into what does developing with Docker mean for the ARM ecosystem? What's enabled and what works today?
Yeah, I mean, I think that I think that we've been working with ARM on enabling things actually for a really long time. I mean, I think it was one of the things I started. I've been at Docker for 5 years now, and I think one of the early things I worked on was ARM enablement, and I think, I mean, things have been happening before that as well. So I think the answer is that really, you know, Docker's a kind of cross-platform set of tools, and a huge amount of stuff does work really well on ARM and has done for a long time. And an ever-increasing amount of development work is happening on Docker with ARM. So really the kind of, the basic Docker experience of building, sharing, and running containers works cross-platform and supports multiple architectures really well. And so so people have been using it on ARM for many years, and that side of things is really good. Some of the tooling we'll talk about, kind of later on, is there's bits of work still to do, and the ARM ecosystem is obviously expanding, and there's more work to do. But the the kind of basic tooling of I want to build containers, I want to build cloud native applications, and all that stuff works really well on ARM.
Excellent. Yes, I agree. It's been a journey, Justin. And I guess 1.5 years ago at DockerCon 2019, we announced the integration of QEMU in the Docker development environment. And that enabled the creation of ARM images simultaneously to x86 in a x86 development environment. I'd like to just explore that a little further with you, Justin, and really focus on how that has matured since its initial launch.
Yeah, completely. So the idea with this work was that, like, a lot of the time developers have just a Windows machine or whatever that isn't running ARM, but they're developing ARM software. And this is kind of, it can be inconvenient because you want to do a majority of your work on your local machine because it's convenient, and you don't want to have to log into another machine and so on. So and also a lot of CI systems and things, and that don't yet, especially 1.5 years ago, didn't support multi-arch so well. That's starting to change recently. But so what QEMU is a emulator that can emulate, among other things, ARM on Intel machines. So we integrated that. Originally, we integrated as a kind of experiment with Docker Desktop, and then and so which let you run an ARM container on an Intel desktop machine. But then the work we did 1.5 years ago was to actually integrate this better into build, so that you could do automated builds really easily across multiple platforms at once. And since then, we've also integrated this recently into GitHub Actions, which I can just show you a demo of how this all actually
awesome
works in GitHub Actions. So let me share my screen. And
so what are you running on, Justin, just out of curiosity?
I'm running on a Mac here, but I also have I have a collection of other machines. I have a Raspberry Pi that lives under my desk, which I'm logged into logged in over here. This is my Raspberry Pi. I've got a Raspberry Pi. I've got the kind of running 64-bit.
Yep.
So I'm running the 64-bit Raspbian, which is now been out for a while. I also have I have an ARM Windows machine over here as well, which we can talk about a little bit later on. And I'm also logged into a collection of other remote machines, which we'll talk about in a bit as well. So you've got plenty of, I've got my working from home set up, you know, so it's got all these machines handy for when I need to do things. It's kind of nice. So yeah, we've been working quite a bit on GitHub Actions recently. So GitHub Actions is a CI environment that has a lot of developers have started using recently. We've noticed it's like exploded in popularity. It was launched, I think, a year ago now. But certainly for a lot of the work we do, we've switched over to using it. And so it's basically an automated workflow. I mean, especially if you're using GitHub already, it's an automated workflow for building, which you can use for building container images and things that works really, really simply. And so what I want to show you here is basically a really simple use case of it for building multi-arch images. So if I could go to my Mac here, I've got this, I just set up a very, very simple Hello World application in Go because it was kind of convenient, and this prints Hello World and it prints whichever architecture it's running on. So it'll, if I build it locally and I run it, it'll say Hello World AMD64 because I'm running on my Mac. But if I want to build this, let's modify this a little bit, and so I say hello world developers, and then I let's just change this and I'll push it to GitHub. And we can, if you look at the authenticate, Mark, you notice I've got hardware authentication for my GitHub pushes. I've been testing this recently for reasons we can talk about later as well. I've been testing the workflows for using the Apple Touch Bar as for authenticating GitHub. I've been using it for a few months now. It's actually quite nice.
Nice.
So let's make this a bit bigger. This is my the GitHub workflow I have, and so this is the new Docker GitHub Actions that we relaunched recently at version. We kind of relaunched a version 2 of our build actions, which support multi-arch properly, and it's this is the sort of YAML format that GitHub uses. So basically, this is a set of actions that checks out our code. It sets up the QEMU emulation with the version 1 of that. There's only been one release. So set up QEMU here. Sets up BuildX, which is the builder that supports multi-arch. So we've got this as the new BuildX action. So that sets that up. This bit just sets up the version, how we want to tag it in the build date for metadata. We log into Docker Hub. So we'll talk a bit more about Docker Hub in a minute, but Docker Hub is Docker's container repository where you can store all your containers, including your multi-arch containers. So we log in, and then this is our build push action version 2, which is the new one that we launched that supports this multi-arch properly. And we say we want to build with a Docker file, which you can just say platforms AMD64 and ARM64. It's just, that's all you need to say. Push it, and then this is which repository I'm pushing it to. I'm pushing it as latest and a tagged version, and lots of metadata because I knew Gareth would be on the call, so we needed some metadata. So if we go to the Actions tab on this repo, this is the commit we just did. It passed and built, completed 1 minute 17 seconds. And you can, I just have to shrink this a bit because it's too big to have to see it, but considered that. So we can now pull this image from if I spell it correctly, multi-arch actions, and then we can run it, and it says, hello, well, developers ARM64. And now if I go to my Raspberry Pi over here, I can pull that here. And I can run it here, and we get hello with ARM64. So we've run the same image that I built from that updated code that I pushed to GitHub on my GitHub action. It's built it for multiple architectures at once, and I can run it on my Raspberry Pi or on my Mac with the same code, and it tells me what architecture it's running on. So it's done everything for us automatically, just using emulation on GitHub Actions. So it's basically it's running on the GitHub Actions default runners, which are x86 machines, but it's built it for both x86 and for ARM64 at the same time, and I can just use that. So I could test my image running locally on my Mac, and then I could also just push it up, and then I could test
Justin?
it on my Raspberry Pi. Yep.
A question popped up in the chat here, if you don't mind.
Yep.
This is from David. He's asking if you're using Docker Compose, or if this is using Docker Compose.
No, so this was just a very, very straightforward example of just running a single Docker container without Docker Compose, but Docker Compose works in exactly the same way was that. I should have done a Docker Compose demo too, but.
Justin, is it possible to grow that text? I'm having a hard time reading.
Oh yeah, sorry.
This console itself.
Okay, I will grow. There's no annoying. It's very annoying on these consoles. You have to grow them individually, and then grows the size of the window, and then you have to. So I will grow them all before I use them.
So this is pretty exciting. You're able to do a build, like go onto GitHub Actions, set up a CI, do a build using QEMU, and then your images that you're generating are multi-arc, and you can pull what you've generated from either platform, and the result is the same. You're getting your application up and running.
Yeah.
Very cool. Oh, I love it. So this is quite interesting. So you're demonstrating what we've accomplished and what's been built on since that initial integration with QEMU. Now, we're seeing more and more opportunities with ARM development environments coming together directly on ARM processors. We have Windows with the WSL environment, WSL2, which is quite easy to use, easy to get a Linux distribution on, easy to run Docker, CLI. There's also, the Graviton instances in the cloud, which are offering great benefits for compute, intensive workloads, increasing performance and decreasing cost. Why don't we talk a little bit about what Docker is doing to support developers on these ARM development machines? And also, you mentioned the hub. I think it would be great to touch on that one a little more as well, Justin, and just tell the audience here what's enabled and what works with the Docker hub around the ARM environment.
Yeah, so so Docker has his Docker hub. I was just searching for Nginx, for example, and you can. With the search, you can search by architecture. So I can search for ARM64 images, but the vast majority of things like these official images, there's the official Nginx build, for example. These are almost all available for ARM and have been for some time. So if I want to, run Nginx on my Raspberry Pi, I just do Docker run Nginx, and it just it just runs. And there, and it's just there. So all the all the kind of common development things you want are available for ARM64, and you know, because it's getting easier to build stuff, and more stuff is happening. I mean, we've been talking to Rancher today. They have a lot of, they have most of their content, for example, is available for ARM64, because again, they're working with a lot of people who are working on the edge content. So you can see that Rancher Agent is available for ARM64, Rancher OS.
Justin?
Yeah.
Can I squeeze a couple more questions in here real quick?
Yeah.
Okay, great. So this one's from Kushal. He's asking, I think this has to do back when you were running the ARM runners demo. He's asking, are you using self-hosted GHA ARM runners to build for ARM, or is it being built using Docker BuildX?
So that example I gave you is BuildX. In a few minutes, I'm going to show you a self-hosted runner and how to set that up as well. So we'll cover that in a minute. I've got another demo on that.
Okay. There's another question here from David, and he's asking, I think this is more related to what you're talking about now, is can we develop for Cortex-M or just Linux-based Cortex-A type devices?
Yeah, so basically, containers give you a development environment, and you can, they're very useful for running a standalone development environment and doing your development in a reproducible way, where you set up a development environment with everything you need to do your build. So I mean, I can Docker run Ubuntu, and I can pull up the latest copy of Ubuntu, and I can install the development environment, and I can save this to Docker Hub and come back to it later and things like that. Containers currently support Linux and Windows environments on ARM and Intel, but you can't directly run Docker containers on, say, an M environment, but you can have a development environment for M, and you can run the emulators and all the other pieces you need to give developers an easy to work environment that helps them. Has the tool. You can have containers with the development tool chains pre-installed in them with the right versions that work, which I know from my long experience working in embedded systems is always having the right tool chains and having them built is always a pain. And so having these things centralized using containers is really helpful. But at the moment you can't actually run containers on something like an M environment directly.
Currently, those are the only questions in the chat. So thank you, Justin. Hopefully that answered them.
Thanks, Robert.
So there's a lot of common software available, and development tooling and all those things are all available for ARM. If you really most things you look for on Docker Hub are going to be there for ARM for the kind of core content that you need for development. What else were you asking, Mark?
Yeah, so you've got the Docker Hub environment here. What about the development environment on ARM native platforms?
So at the moment, so Docker Desktop, which is this little whale menu here, with the dashboard for Docker Desktop. This is not yet available on ARM developer systems, but as Apple announced at their conference when they announced their Apple Silicon support, it is coming for the Apple Silicon Macs, and then also you can run Docker on the ARM. We don't have a packaged version of desktop for ARM Windows machines, but you can run Docker. So I've got a machine here. This is my Windows. This is my Windows ARM machine here. So I can log into that
That's a Samsung device, Justin, running
Yeah,
Windows 10?
Yeah, so this is a Samsung device, and I've set up SSH on it so I can log into Windows, and then I can you can log into Windows, and then so you can run SSH on Windows. Yes, I'm using my fingerprint SSH logins as well.
Nice.
It's all hardware,
Nice.
all hardware keys around here, and then I'm in Windows here, so I can and then I can go into Bash, which is the Linux environment of the WSL2 Linux environment, and then I've got a I've now got an ARM Linux running Microsoft standard Linux. It's funny to see this after all these years, running on ARM64 here, and then I can again I can do my that container my RTH actions. Oops, Docker. I can run that here, and again, so that's pulling that, and so I'm running that on my Windows Dev machine, and that's run on there. So you see, I've got exactly the same Linux development environment with Docker here, so I can build all my containers, and this obviously runs native ARM64 containers. So that's not set up with Docker Desktop, but if you follow the normal Linux installation instructions, which you can get from just the Docker documentation for it, I'm going to install on Linux, then those instructions will give you a kind of perfectly normal Docker development environment on Windows, which works really nicely, and you can use it locally or SSH in or whatever you want. So you've got a nice portable ARM64 environment on Windows there. We've got an issue on our roadmap for adding support for WSL2 on Windows ARM, which if you want to upvote this on our roadmap, go to github.com/docker/roadmap. There's been quite a lot of interest on the WSL2 ARM Windows. So there's quite a lot of people asking for that. So upvote it and let our product managers know that that's what you're looking for. But yeah, so it's not a packaged product yet, but it does work nicely, and so we would like to package that up in future as an integrated, with the integrated desktop experience. And then the Apple we're waiting for the Apple hardware to ship sometime, in the next few months, which will be really exciting, because that means there'll be a lot more desktop hardware, and there's all the Microsoft Surface X. Surface X is the
Surface Pro X.
Surface Pro X, which is the ARM version of that. So I know a lot of people have that machine. It's supposed to be really nice.
It is. I have it here, and honestly, it's being able to use all your Office tools in a Windows environment that I'm comfortable with, and then having that window into Linux, and I was able to pick a distro off their app store and install it in the Linux subsystem flawlessly. It was really nice, for sure.
Justin, we do have another question here. This is from David again. Oh, looks like you just shared it. Oh wait, no, I think he found you. So basically he's asking, can we obtain copies of the files you're using? Perhaps your GitHub repositories are public?
No, completely. So the multi-arch actions demo that I just did is here, and then I'll explain. So I'll explain in a second about but I'll make the other one public as well. But yeah, so you can always find me on the internet at Justin Cormack. I'm Justin Cormack on GitHub and Twitter and everything, so it's easy to find things. And feel free to open issues, ask me questions on this as well if it's not clear at all and you want help. And then there's the Docker GitHub Actions the build push action has has additional links to the documentation for for the Docker GitHub Actions, and we're working on other docs for other CI providers, because there's a lot more ways of doing ARM built-in CI now. So Travis CI has ARM support, and Drone has ARM support as well. So I think there's and a couple of others. So because I know that ARM has been working with the CI providers to help expand the ecosystem for things. But yeah, I can show you the self-hosted runner. So that was the other question about. So with GitHub, you can either use the built-in the QEMU and run on the built-in hosts, which basically is quite convenient because you don't have to do much. But running QEMU is a bit slower than running natively on ARM. And if you have particularly a large project that takes a long time to build, you probably want to have a native runner. So you can self-host your own runner and basically set that up to basically do the builds under GitHub Actions for you. So what I've done here is I've gone and set up a Graviton machine on AWS. So this is one of the so the Graviton machines are really nice, fast. ARM64 machines. This one is actually a small one, so I didn't get. It's only the small. This is the smallest size one I chose, but the you can get them anything from tiny to gigantic, which is kind of convenient depending on what kind of workloads you've got. I can't remember. They've got 64 cores, or I think the large ones. If you take these machines and you look, it's actually running the GitHub runner service here. I can make this a bit bigger. So basically, there's a set of instructions to set up the runner. It's relatively straightforward. You download this tarball and unpack it, and there's basically a set of scripts. So run.sh basically just sets up. Run.sh just sets up the runner just to run it once, and runs this listener process. And at that point, it connects to GitHub. And if you look in, if you look in the settings of the repo in Actions, it will tell you that you've got Graviton self-hosted. Oh dear, offline it says. So let's run this run script again, and oh dear. I know what this issue was really annoying. This issue is actually an issue with Amazon Linux, and if Amazon Linux has a slightly annoying config issue with the version of the runtime for .NET Core, and so I found this issue the other day, and I went and I badgered Amazon, and they are about to fix it. So it should be fixed any day now. So you will never have to deal with this issue.
You didn't make enough sacrifices today.
And so now I have to find the file which I edited the thing to actually fix it. Which
so you're running this one right on the Amazon server, then, right, Justin?
Yeah, so I'm running this is running the GitHub Actions runner, and I have to remember where the config file was and what it was called to fix this, because it's a, what is it?
This is actually a question from David then. So this, what are these machines running on GitHub, AWS Docker? But this is a Docker, or sorry, a GitLab runner on AWS server. Is that what it is?
GitHub runner on AWS server.
Sorry, GitHub runner,
which
on
I'm then
AWS
using to basically to build that. So the GitHub runner, you can basically, you plug it into your GitHub Actions, and then it will, you can give it labels, and it'll say ARM64, and this will run any ARM64 jobs that need to be run. And if you look at my actions config in the workflows directory, you can see that in the config here, I've written runs on self-hosted Linux ARM64. So I'm saying I want this action to run on a self-hosted ARM64 machine because I've set one up because this is going to run on native builds. I'm going to try and remember where the which repo I filed the issue was open in.
It's okay. While you're looking, we still seem to be getting some more questions in here. So while you're looking, maybe you could try to answer these as well.
Yeah, sure.
Shaul asks, does GitHub offer managed ARM64 runners as opposed to self-hosted runners, just like they do for x86?
No, the answer is they don't at the moment. GitHub Actions runs on Azure pipelines, and Azure pipelines don't currently have ARM64 machines available. Do ask Microsoft if you want. So you have to run self-hosted ones. Yeah, so you basically have to run your own at the moment.
Thanks. Hopefully that answers your question, Kushal.
Other questions? I'm just trying to remember where this config file was.
Those are the only questions right now, but I do encourage, while Justin is looking for the stuff, if there's anyone else that would like to speak up.
I've got a question for you, Justin. You mentioned Cortex-M. Is it possible to develop for Cortex-M inside a container on Arch 64? So say you were developing, right?
Yeah, so if you're just developing, I mean, I think, keeping your development environment and stuff in that is very straightforward. And so
I would imagine that's a great way to develop your code, targeting a M-class device in a cloud native environment, and then leveraging all the cloud native tools to kind of help facilitate that development.
Yeah.
Debugging, joint, working collaboration on code, all the great stuff.
Yeah, no, completely, definitely. Okay, so I think this is, I believe this is the right config file. And so what I've added as it can play is system globalization environment true. I think there are a couple of places I had to edit yesterday. I don't know why it's reverted. Maybe I updated it itself. Anyway, so I'm going to try running this again. Oh, yes. Okay, so we should now, it already has an active session. Retrying. Oh, well, connected to GitHub. Let's see if GitHub now says So let's go to self-hosted. Let's go to settings. Let's go to actions. And yes, it now says our host is idle, which is great. So we're now running, we've got a self-hosted runner. And so what this does is it's the same workflow as above, but it just does a straightforward native build. So all it does is Dockerfile and push to Docker Hub. So I'm going to go to here. I'm just going to change something. Let's change main again. And I'm going to say, change that. And then let's add that, commit it. And let's push that. And then we should, if we go to the actions here on this, we'll see that it's now started to build the orange thing, it's queued. And if we go to, she's probably, we should, hopefully it will unqueue in a minute. If we're lucky, but that's basically, so that's still key. It's definitely confused by whether it's got more than one session or not. I think there's not, and it's not. I think quickly hack together runner clearly is not robustly implemented.
That's all right, Justin. This is good. Like, this really demonstrates, how a developer can build on ARM, leverage Graviton instances, do things around CI. It's definitely a lot further along than it was when we initially started the engagement a year and a half ago. So that's pretty cool. I think there's a couple of other projects that would be just great to mention and maybe explore a little bit. I know we are running out of time. I think we got 3 minutes left till the end of this session, but as Robert mentioned in the chat, we can stay on for an extra 15 minutes to close this up and answer questions. But by all means, if you feel like you need to leave, go ahead. You'll be able to watch the recording later on. So going back to these projects now, we've got this development environment that is being enabled and working natively on ARM. There's another project around security scanning that was recently announced by snyk.io. Their scanning tool is now enabled for x86 and ARM images, which is great. And I know that Docker is leveraging the snyk tools for scanning. So that's pretty exciting.
Yeah, so we just launched scanning on Docker Hub with Snyk a few minutes ago. Like literally.
Really?
And it's on desktop as well. So we haven't got the ARM support yet, but it should be coming soon. So at the moment, our support is x86 only, but yeah, it's definitely it should be available shortly. So you can basically do Docker scan Nginx and it will analyze dependencies and look for security issues in Nginx. So that's available on desktop as well as in Docker Hub. And so here here's a bunch of vulnerability it found in Nginx. So this functionality is available through the SNCC CLI for ARM right now, I believe.
Yep. Yep.
And it should be available through Docker as well soon.
So Justin, can you just elaborate a little bit? Like SNCC as a scanning tool, you've mentioned it's sitting in available in Hub and available in desktop. So what's the difference? Why would the developer want to have that an ability in Hub as well as desktop?
Well, so I mean, it's part of the reason why we partnered with SNCC was that they have a solution that's really developer focused, as well as for end users to actually find security issues in their stuff like as soon as possible, because that's the best time to fix things. So SNCC has always had a focus on workflows directly for the developer, but the workflows on Hub are also really useful because you can share them with your team, and you can basically look up things later and see what's happening in with vulnerabilities for images that are in production and things like that. But the the best time to finish is to fix security issues is really right at the beginning, when you're actually working on something and you're like, oh, I'm using a new package, I should scan it for security vulnerabilities to make sure it hasn't got anything I shouldn't be using, and those kinds of things. So that's it's really important for developers to have those tools to hand all the time.
Yeah, agreed. And it like you said at the beginning, right? Docker is focused on the developers, and this is getting the ability to scan images at the fingertips of developers, which is ideal.
Yeah, I mean, I think the whole kind of point of the kind of cloud native developer tooling is to have everything at hand to developers and easy to deploy and easy to run and easy to use, so that you can things that would be kind of difficult in a traditional environment become really easy to do.
If I may, real quick here, I just want to let everyone know that the time did run up on this session 2 minutes ago. Marc did mention this. Feel free to move on to your next session, but we will continue on here for roughly another 13 minutes. So sorry for interrupting there, but thank you. Just wanted to make sure that was reiterated on.
Thanks, Robert. And you'll probably notice also in the chat that Gareth is sending information around Snyk. Gareth is the product manager at Snyk, another colleague of ours from Docker, who moved over to Snyk. So shout out to Gareth. Happy to see you on and providing information here. I have one other section or topic to bring up, Justin. About a year or so ago, we started a project called PARSEC. And PARSEC, at the time, we were looking at how to abstract security primitives in devices such that the cloud native development model could continue on into devices that would have distinct root of trust, all different. But we didn't want to tie, the applications to those root of trust. So I'm wondering, Justin, how PARSEC works with Docker, and given the refocus on the developer community, if there's anything that you see in the horizon around PARSEC intersecting with Docker.
Yeah. So when we started working on it, a lot of the drive for that, from my point of view, came from the fact that our customers, particularly customers in financial services and government and things, particularly they were kind of early adopters, really were saying that cryptographic private keys should be stored in hardware and not just in software. And one of the things, as environments become more security focused, there are more and more keys that have to be managed by developers, because it's just they're proliferating, because everything everything has signing keys for, whether it's for container images or for git commits or what or whatever you're doing. There are or for your production environments and so on. And developers have to manage more with secrets and access control and those sorts of things. And so keys that are only in software are very easy to exfiltrate and to get stolen. You don't really know what's happened, and you don't know when they're being used. Whereas if keys in hardware you generally have the hardware is generally designed with a way that you know when it's been accessed and you have control over the access process and you know when your key has been used. So one of the things about my SSH key pop up whenever I log in or get push something is that I know that I know that hardware key is being used. It's not cached anywhere, and I have to put my finger on the fingerprint reader on my Mac, which is actually running, of course, an ARM CPU under there, running a secure operating system separate from the Mac that manages the keys. So you know that's happening, and you have control, and you have information about what's asking for your key and why, and it does. Whereas if you have a key in software, any program could ask for it at any time, and you really have very little control over that. So these things are definitely becoming more important for developers over time as they become more conscious of the importance of things like identity and encryption and so on. There's a whole bunch of working groups around developer identity and identifying where things come from, and then there's the work we're doing on Notary V2 for container signing and those workflows. There's also a lot of work on things like workload identities and things like that with Spiffy and other projects like that. So there's a lot of areas in which keys have become much more important for developers, and because of that, hardware keys are have those useful properties, hard to exfiltrate, tied to specific machines, so if your thing's supposed to run on this machine, it is running on this machine, and those kinds of properties which are useful to increase trust in where and how things and processes are actually happening. So you know things are happening where they're supposed to be, and which there's a whole kind of area of supply chain security about where do things come from, and have they been through the right processes in the right places from the right people, and all those things are driven by keys, and all those keys are ideally hardware keys.
Clearly quite passionate about the security of development, right, Justin?
Well, I mean, it's supply chain security attacks have been something that's been increasing a lot. It's
absolutely.
It turns out that it's quite often it's easy to attack things at the source rather than trying to attack them when they're in production. If you can just modify the code before it even goes out, or you can persuade someone to incorporate something in their code that gives you backdoor, then that's much easier.
All right. Well, this concludes our segment of the talk where questions are curated and we're going through our script. So I want to thank Justin for all this information. I think it's been very good. Any more questions, Robert, on our line?
No. I mean, there were some questions about where the show was going to be hosted, or sorry, where this session was going to be hosted. And I guess, yeah, I'll answer that real quick. After this is over, within 24 hours or so, all of the sessions that were hosted on a Zoom channel, this includes workshops, ecosystem talks, and office hours, you can find those on the ARM Software Developers YouTube channel. So within a 24-hour period after we close this one out, you will be able to access it on the ARM Software Developers YouTube channel. You can also, of course, access it through the DevSummit platform. So I would definitely suggest checking out both of those areas. Subscribe to. But Justin, Marc, awesome. Thank you so much for spending your time here and during the ecosystem chat.
Great.
Thanks.
Happy to be here. Thanks.
Are we closing this out now?
I think it makes sense. We got no other questions coming in. One last call out.
Okay, perfect.
Nothing else. Excellent.
Excellent. Yeah. All right. Well, then, thank you so much, everyone. Once again, Justin, Marc, thank you very much for your time. Keep your eyes out for the platform. This video will be uploaded there. You'll be able to view it later on. Anyone else that would like to contact us, you can do so through the Discord that we shared and or on YouTube. All right, everyone, take care.
Take care. Bye.
Bye.